Good day, ladies and gentlemen. My name is Helene-Marie and I will be telling you a bit about a piece of my project, which is about technology selection for mine waste reuse. Now, mine waste, there's typically not a lot known about it, and so we strove to overcome that data and information deficiency by asking experts for their input. So the background is that mining typically produces large volumes of waste, which then has a pollution impact on the surrounding environment. In the case of my case study, which is fine coal mining waste in South Africa, that pollution is acid rock drainage related. And this then leads to land degradation and health effects. And just as an example, this is an aerial image from Google Earth of an area in Imalahleni or near Imalahleni, and you can see the dark spots represented by the coal mines, and then there are huge waste impoundments all over the area. And this is obviously not a sustainable way of running an operation, and there are a few ways you can do to make it better, but I would put forth that reusing mine waste is an option that should seriously be considered. It improves resource efficiency by using, to the greatest extent possible, everything that you take out of the earth. And when you use that material, it's not available for pollution production, at least directly. But mine waste can be quite, can be poorly characterized, heterogeneous and complex, which means that we don't know a lot about mine waste typically. And there are very few ready developed technologies available for using mine waste. And anyway, any technology that you do want to use would have to be adapted for your specific mine waste because of the heterogeneity aspect. And to navigate this murky environment, I've adapted the innovation value chain to suit this environment. And I could talk about this for a while, but I'm going to be focusing on the selection bit for today. So how do people generally select technologies for early stage development? A common way is using a method called satisficing, which basically means looking through the available alternatives until a minimum acceptability threshold is met. And you obviously don't select necessarily the best technology in this way. And it also depends on the project team's preferences and experiences and hunches. It's not a very structured way of working through alternatives. A more structured way is the Pew matrix, in which different criteria are identified and alternatives are rated against a reference alternative to on the different criteria. So there might be better in criterion 1 and the same in criterion 2. But the problem with this is that it's not transferable. So if you use a different alternative as a base alternative, you might get a different outcome. And then you could also use a decision flow chart, but they don't allow trade-off with different criteria and also not degrees of agreement with the question. So the way that we've gone about using or discerning between the alternatives is using multiple criteria decision analysis, and a rate and rank method. And we identified 4 different criteria groups: technical, social, economic, and environmental. And this is in an effort to really make sure that we don't miss an important aspect of the different technologies. So there are 4 to 5 criteria in each group. We identified some alternatives for applying our material. And then we asked several experts to individually rate the technologies. We gave them constructed scales so that a 0 and a 4 hopefully means the same to everyone. And then they gave us their ratings, which we then aggregated using the decision makers' weights, so the decision makers' preferences. And the key questions that this presentation is looking at, trying to answer, is does the quality of the expert make any difference when you are looking at this, when you're trying to make a decision? And do conducting interviews add any value, because they do add complexity to your research design. And so our approach to answer these questions have been to select some experts, some professionals in mining and process engineering. And so what we then got from that is a whole bunch of ratings by all the experts. And then my decision makers selected a few of these experts, whom they really respect and consider to be, experts in their fields with years of experience. And so we also aggregated them separately as well. Now, in cases where these trusted experts disagreed with each other, or where one disagreed with the rest, I then went in and did interviews with them to try and understand why there is such a big difference. And so then and they had the option to redo their ratings if they chose to do it that way. And so we then have a next set of ratings by trusted experts after the interviews, and also some interview transcripts. Sorry, wrong way. And these are the results. And I can assume that everybody will look at this and see, the first thing they see is that there is no Y axis. And the reason for that is that the length of the bar is really, it's a dimensionless number that is really only useful in comparing with the other technologies as bars. So it's a metric for comparison and not valuable as a measure of anything in and of itself. So what you need to know is that a longer bar is a better bar. And from this, you can see that the results show that actually the outcomes are pretty similar. It's pretty stable. Soil amelioration tends to come out tops in most cases, at least second from top in this case. Ferrous sulfate and chromium 6 reduction tends to come out at the bottom consistently. And so what this shows to me is that there really isn't much of a difference between the all experts and the trusted experts. So your trusted experts, that distinction doesn't make a big difference in the outcomes of the decision-making decision support process. Doing interviews did seem to help in the sense that they clarified or made the distinction between the top, the middle, and the bottom performers more clear, which gives you more comfort that you are in fact choosing the best technology to develop further. And so based on this, one might say that you can just choose a bunch of people, ask them to rate, and you'll get a pretty good answer. But this masks quite a bit of variability in the data. You can see only really the soil amelioration in this case, or the top performers, are able to dominate the bottom performers. In other words, their standard deviations, the error bars that indicate standard deviations, don't overlap. And so, yeah, there's a whole lot of uncertainty in this data. To try and to see that or interrogate that a little bit more, I separated my experts into groups: process engineers, academics, industry researchers, and industry professionals. And as you can see, their ratings gave widely different outcomes. For instance, the industry professionals thought that soil amelioration was definitely the first technology to be looked at, whereas the industry researchers, their ratings indicate that ferrous sulfate should be the first technology that we look at. And based on, if you can remember the previous slides, ferrous sulfate was consistently in the bottom two. So if you just asked industry researchers, you would interrogate a completely different set of technologies. Again, with the academics, a completely different set of technologies, and then process engineers and overall. And so it doesn't necessarily matter as much when you're trusted experts, but what does matter is your groupings of experts. The next question, are interviews useful? I would say they're more nuanced, more deep. They can go deeper. For example, this is my one rater who spoke about processes using heap leaching, and they identified that the pH profile in the heap would be a real issue, as well as the geocode process, which could add complexity to the process. And so you're able to get more information on why a certain technology got a certain rating, which then gives you a better idea of where to start your development work. can also give some broader reach. This expert linked the low feedstock quality or the variable feedstock quality to variable product quality, which then relates to markets, available markets. And so that was a very useful input from their side. And it was able to link different criteria and show how they interact. So they give you a fuller understanding of the technology, and they're more likely to surprise you. You're more likely to have an outcome that you didn't expect. And so conclusions, trusted experts assessments does not lead to different outcomes, but stakeholder groupings do matter. And interviews can be useful in guiding development. And on that last point, you're welcome to ask me afterwards if you have any questions. And the link to sustainability, intensifying resource use and avoiding environmental and social externalities. So this feeds into the circular. Thank you very much.